Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for Ncert and 10th standard Cbse for mathematics and science classes. So today we will be going with the conceptual problems based on similar triangles, that is all the three criterions for similarity, that is AA criterion for similarity of triangles, SAS criterion for similarity of triangles and SSS similarity criterion for similarity of triangles. Okay, anyway, so all these three criterions, in the last three sessions we have given the proof for all the three criteria. So I hope you have enjoyed all the three criteria, how we get it. So out of all the three criteria, the first criteria, that is AA criterion, is very important. And apart from that, it will be in your examinations, it will be asked for 4 marks. You have to practice. Don't practice theorems without diagrams. Please use diagrams with different names. Don't get attached to the textbook. Come out of the textbook. For the sake of knowledge, please write down different names for the diagrams and give your own proof. Practice making or writing proof for a theorem in that way, right? And while writing proof, you should give reason for each and every step wherever it is required. So that's very important. That's the way of writing, presenting theorems in examinations, right? So at the end of this academic year, maybe we'll be celebrating theorem festivals also, so which is a part of our academics. We usually do it. So how we do it, all these things you are going to come across in the coming sessions, right? So in today's session we will be going with very important, that is we are going to apply what we have learnt in theorems for similar triangles. So these problems are going to build up the concept of similarity of triangles. So here 2 triangles will be given to you. You have to check the triangles and we have to name whether we have to name the similar triangles in a very systematic, scientific manner, and we have to check whether the given triangles are similar or not. If they are similar, we have to write the criteria which is being used, and also we have to write the symbolic representation of the names of the triangles. And if it is not similar, if they are not similar triangles, so no need to write any criteria, right? So we have the problems on board. So state which pairs of triangles are similar. So that's the first question. State which pairs of similar triangles are similar. Write the similarity criterion which is used for similarity, because in your hand you have 3 criteria. If 2 triangles are equiangular, then they are similar. If 2 triangles are equiangular, then their corresponding sides are proportional. This is A criterion. Second one is SAS criterion. If two sides and an include angle of one triangle are correspondingly equal to, that is the corresponding angles are equal and the sides containing those 2 angles are proportional, then the 2 triangles are similar to each other, that is SAS criterion. So if the sides of 2 triangles are proportional, then the triangles are similar. This is SSS criterion. So these 3 criteria you are having now. So using that, you have to state which pairs of triangles are similar. We have to write the similarity criterion which is being used and write the pairs of similar triangles in symbolic form. So that's, if they are similar, we have to do all these things, right? So let us get in the first problem. So this is triangle ABC and this is triangle PQR. So angle A measures 60 degrees, angle P measures 60 degrees, angle B measures 80 degrees and Q measures 80. Angle C measures 40 and angle R also measures 40 degrees. So we will take up the triangles. So in triangle ABC and triangle PQR, angle A is equal to angle P, that is each they are 60 degrees, and angle B is equal to angle Q, angle B is equal to angle Q, so each is 80 degrees. So I hope 2 are enough. A third is also there. Okay, let us take it. So angle C is equal to angle R. So each equal to 40 degrees. Right. So in the first triangle we have 3 angles, and in the second triangle we have the corresponding 3 angles which are all equal. So corresponding angles of both the triangles are equal. So if the corresponding angles of 2 triangles are equal, then the triangles are said to be equiangular. So according to AA criterion, if 2 triangles are equiangular, then they are similar. So this is AA criterion. So therefore triangle ABC is similar to triangle PQR. So you have to write the criterion. So it is AA criterion we are using here, and we have to write the pairs of similar triangles in symbolic form. So let us write it. So therefore triangle ABC, see, vertex A is 60 degrees, 60, 80 and 80, 40 and 40. So therefore triangle ABC is similar to triangle PQR. Is similar to triangle PQR. So this is how we have to conclude. So we have taken 2 triangles. We have discussed how they are similar by using the AA criterion, and we have written the symbolic form of the similar triangles. Right. So let us get into the second problem here. So this is triangle ABC and this is triangle PQR. So in these 2 triangles, angles are not given, just they have given us the sides to check whether they are similar or not. So let us take the triangles. In triangle ABC and triangle PQR. So in both the triangles, let us take the ratio between the corresponding sides. So AB by QR, we can take it. So AB by QR. AB by QR is equal to, AB is 2 and QR is 4, so that becomes 2 by 4 to 1 times 2 times, that is 1 by 2. So now again BC by, we can take PR because it's 2.5 and 5 here, so it is BC by PR is equal to, that is 2.5 by 5, 1 time 2 times, so it is 1 by 2 again. So we can take another ratio, remaining one. So we will take AC and PQ. So AC and PQ are the corresponding sides. So AC by PQ is equal to 3 by 6. 3 ones are 2 times. It is 1 by 2. So here we can see the corresponding sides are proportional. That is, we are getting the same ratio here. So therefore, triangle AB by QR is equal to BC by PR is equal to AC by PQ. AC by PQ. So therefore, triangle ABC is similar to, you should not write PQR because you have to write the similar triangles in the symbolic form. So therefore, triangle ABC and triangle QRP are similar because this side, for this side, this is the corresponding side, for this side, this is the corresponding side, and for this side, this is the corresponding side. So therefore, we have to write the name very, that is, you have to watch it very keenly here. So triangle ABC is similar to triangle QRP. QRP. So this is how you have to write the symbolic things, right? So these are the 2 problems. Still 4 problems are there. We will go one by one. This is triangle L and P, and this is triangle D, E, F. So it is 2.7, 3 and 2. It is 4, 6 and 5. Okay, let us write another one. is triangle MNL and this is triangle PQR. So this is 2.5, this is 70 degrees and this is 5. This is 5, 10 and 70 degrees. Okay, so we'll get into the problem now. It's very simple. State which pairs of triangles are similar, write the similarity criterion used and write the pairs of similar triangles in symbolic form, right? So now, in triangle LMP and triangle DEF, we'll take the triangles LMP and triangle DEF. I have not written it symbolically, just I have named the triangles, that's all. Okay, so let us go with this. MP by DF, these are the corresponding sides, or you can go with MP by DE. MP by DE, 2:4 is 1:2, LP by DF is 3:6, that is 1:2, and 2.7 by EF, that is LM by EF we have to take. There is no other way for this, this is the only go for that. So MP by DE, MP by DE is equal to 2/4, it is 1/2 here, and again it is LP by DF. LP by DF is equal to 3/6, 2 times, that is 1/2 again. So this is LM by EF, that is leftover thing. LM by EF is equal to 2.7 by 5. So here we can see 2 pairs of corresponding sides are proportional, but the third pair is not equal. That is, it is not equal to the ratio 1/2. Here also we should have got 1/2 to make the triangle similar, but according to the given data it is not possible. 2.7 by 5 we are getting. So out of this, if you multiply this by 10 and this by 10, this will become 27 by 50. So then also we cannot get 1/2 here. So therefore we will stop it. So here corresponding sides are not proportional. In these 2 triangles, corresponding sides are not proportional. So therefore corresponding sides are not proportional. Corresponding sides are not proportional. So therefore triangle LMP is not similar to triangle DEF. They are not similar. So as they are not similar, so that the similarity is based on SSS similarity here. Because if you want to come to a conclusion that the triangles are not similar, then also we have to use a criteria here. So according to SSS similarity criterion, triangle LMP is not similar to triangle DEF. So this is enough, right? Okay. So we'll go with the next one. So here we have triangle MNL and triangle PQR. So let us take the ratio. So in triangle MNL and triangle PQR, okay. So here angle M is equal to angle Q. Angle M is equal to angle Q, which is each that is 70 degrees, okay. Then Mn by PQ, we will take the ratio. Mn by PQ is equal to 2.5 by 5. So 2.5 once 2 times, that is ratio is 1/2. Then we will take ML by QR, that is ML by QR is equal to 5/10, that is again 1/2. So here one angle of one triangle is equal to one angle of the other triangle, and the sides containing the angles are proportional. Therefore both the triangles are similar to each other according to Sss Similarity Criterion. So therefore triangle MNL, okay, if you can take it also like NML is equal to like PQR MN, PQ is the corresponding side, for ML, QR is the corresponding side, and this is the vertex which is equal vertices. So therefore you can take it as triangle NML equal to triangle that is similar to triangle PQR. For NM it comes PQ, for ML it comes QR. So you can take it as triangle NML and triangle PQR. So therefore triangle NML is similar to triangle PQR. So this is according to SAS criterion. Right. So this is very important. Naming the triangle symbolically at the end, looking at the figure, that is very important. That plays an important role. We'll go with the fifth problem. Right. So very simple. State again which pairs of triangles are similar, write the similarity criterion used, and write the pairs of similar triangles in symbolic form. Right. So we'll go with this. In triangle ABC and triangle DEF, we'll take the triangles. In triangle ABC and triangle DEF. Okay. So angle A is equal to angle F because these two angles are equal. So angle A is equal to angle F. So each equal to 80 degrees. Right? Okay, then we'll take this one AB by, or I can take BC by EF. BC by EF. So BC by EF is equal to 3 by 6, that comes to 1 by 2. And AB by DF. AB by DF is equal to AB by DF, that is 2.5 by 8. 2.5 by 8, so that comes to 25 by 80. So when you multiply this by 10 and this by 10, it becomes 25 by 80. 5 side is 25 by 5 ones are 5, 5 6 are 30 something, 5 by 16 something. So here ratios are not same, and along with that, if you want to prove the criteria of similar triangles using SAS similarity criterion, if you take this angle, these two are the included sides, that is the sides containing the angle. So here for this angle, these are the two sides containing the angle. For these two we have the values. For this one we have only value for one side which do not have value here. So this is, maybe this goes wrong. So therefore sides containing sides containing angles are not proportional. Sides containing the angles are not proportional, so therefore triangle ABC is not similar to triangle DEF. Okay. So when we come to the sixth problem here, so in triangle DEF and triangle PQR, so angle D is equal to, it's not known, angle E is equal to angle Q. So this is equal to this. So angle E is equal to angle Q. Angle E is equal to angle Q, and angle, but it's not, it's here, but it's not here. We do not know the value here. So angle E is equal to angle Q, that is each 80 degrees. So what we have to do is, for this triangle we have to apply the angle sum property. For triangle DEF we have to apply angle sum property. So in triangle DEF, angle E plus angle D plus angle F is equal to 180 degrees. So we have to substitute the value for angle E, substitute the value for angle D, find out angle F. So this angle F, what we get here, should be equal to this angle. So this one pair of angles is already equal. Another pair of angle we have to check and see whether this angle is equal to this. So if those two angles are equal, if two pairs of angles are equal, so according to AA criterion of similarity, directly we can prove that triangle DEF is similar to triangle PQR. I hope this is a simple homework for you. You will continue with this. Right. So we will get in the next problem. Diagonals AC and BD of trapezium ABCD with AB parallel to DC intersect each other at point O. Point O, using similarity criterion for two triangles. Using similarity triangles for two triangles, show that OA by OC is equal to OB by OD. So this is a identity. Right. So it's a very important problems. So this from this problem will be going with more and more show that problems and prove that problems, which are called as identities and riders. So you have to practice problems, especially those on trapeziums. They are very important. Okay. So let us get into the first one. Diagonals AC and BD of trapezium ABCD. So we have to draw a trapezium here. So we'll take the trapezium. Right. So this is trapezium. Let us take it as A, B, C and D. So ABCD is a trapezium. AC, diagonals AC and BD of trapezium ABCD. So AC is one of the diagonal, BD is one of the diagonal. We have to draw, we have to connect the two vertices, non-consecutive vertices. So when we join the non-consecutive vertices, they two meet at a point with AB parallel to DC. Okay, so exactly AB is parallel to CD or DC here, intersect each other at point O. So once again, ABCD is a trapezium, AC and BD are the diagonals intersecting at point O. Okay. Using similarity criterion for two triangles, show that OA by OC, OA by OC, that is the ratio between OA and OA and OC is equal to the ratio between OB and OD. So for this we have to select these two triangles, that is triangle AOB, this one, and triangle COD, this one. You have to select these two triangles. Very simple problems. Should get a grip here itself, so that you can do well in bigger riders. Okay. So I have to select these two triangles. So let us write the data involved in this. So description of the diagram is data here. So ABCD is a trapezium. ABCD is a trapezium. So AC and BD are diagonals. AC and BD are diagonals. Okay. Very important is AB parallel to DC. So AB parallel to DC. So okay, you have to show that. OA by OC is equal to OB by OD. So now, in show that we have to check the signs which are taken here. One is OA, another is OC, one is OD, another is OB. So these are the four sides which are involved here. So therefore you have to select two triangles where two sides and two sides are included in that. So I selected this triangle because I have OA and OB. I selected this triangle because I have OD and OC. That's very simple. Okay, to show that. So no construction is required. So let us get into the proof. Right. So I will have selected two triangles. One is this, another is this. I hope you can see this. I have shaded the triangles. So in triangle AOB and triangle COD, in triangle AOB and triangle COD, in triangle AOB and triangle COD. Now, as DC and AB are parallel to each other, we can take this as the transversal, that is BD as the transversal, right? So if you take BD, these are the two parallel lines. Consider these are the two parallel lines and this as the transversal. So if a transversal cuts two parallel lines, then we know that the alternate angles are equal. So therefore, angle ABO, that is this angle, is equal to angle ODC, this angle. Right? So these are the two lines which are parallel to each other and this is the transversal. So if a transversal cuts two parallel lines, then alternate angles are equal. So as I have named the first triangle as triangle AOB, I have to select the angle, this angle first and then this angle. Okay. So in triangle AOB and triangle COD, angle ABO, that is this angle, is equal to angle ODC. So this is the alternate angles, right? So angle ABO is equal to angle ODC. We have to write the reason here. So it is alternate angles. They are alternate angles. So we can also get another pair. So these are the two lines which are parallel to each other according to the data. So if you consider this as the transversal, this line as the transversal, then in this triangle, angle BAO, that is this angle BAO is equal to angle OCD, that is this angle. Okay, so now they become the alternate angles. So angle BAO is equal to angle OCD. Angle BAO is equal to angle OCD. So again, the reason is alternate angles. Alright, so very nice. So in triangle AOB and triangle COD, we have two pairs of corresponding angles which are equal. So in order to prove two triangles to be similar, just it is enough to show that their two pairs of corresponding angles are equal. So according to AA similarity. So third pair is also equal because that is this one, that is vertically opposite angles. So these are the two vertically opposite angles, that is angle AOB is equal to angle COD. No need to write in proving similarity, because in order to prove similarity of two triangles using A criterion, just two pairs of corresponding angles are equal. It is enough to show that. So therefore triangle AOB is similar to triangle COD. So this is according to AA criterion, right? So now the triangles are both similar to each other. Now if once we prove that if two triangles are similar, we get the rights to speak about their corresponding sides. So now let us take the corresponding sides. So we can write all the three pairs, three ratios, and then we will take the required proof. We will practice that. So now in this triangle, that is in triangle AOB, for this double mark, opposite is OB. In this triangle, for double mark, opposite is OD. So therefore OB by OD. This is how we have to identify the corresponding sides. Once again, in triangle AOB, for double mark, opposite side is OB, and in this triangle, for double mark, opposite side is OD. So therefore OB and OD are the corresponding sides. So therefore OB by OD is equal to, now in triangle AOB, for single mark, opposite side is OA. In this triangle, for single mark, opposite side is OC. So therefore OA and OC are the corresponding sides. So therefore OA by OC is equal to, now for in triangle AOB, for triple mark, opposite side is AB, and in this triangle, for triple mark, opposite side is DC. Therefore AB by DC. AB by DC. So you have to write the reason. So corresponding sides are proportional. Corresponding sides are proportional. So here, out of these three ratios, we have to prove this one. That is OB by OD is equal to OA by OC. That's enough. So this is not required. Just we will ignore it. So therefore, OA by OC I have here, OB by OD I have here. Just we will write these two. So therefore, OA by OC is equal to OB by OD. Hence it is proved. So in this problem, it appears to be very simple, but most of the students, they come until here without any problem. They write until here. When they start writing the pairs of corresponding sides, they start doing silly mistakes. So very simple. Therefore, I have marked the triangle, marked the angles in both the triangles very systematically. So you have to follow this method only, which doesn't make you to do any simple errors or silly mistakes during writing the corresponding sides. Once you successfully write this corresponding sides, it will be easy to prove anything you want. So marking the angles while solving problems is very important. So don't ignore this. Just I am not drawing these single mark, double mark, triple mark, all these things to make the diagram more visible, more attractive or something like that. It is a part of the problem. You have to show the evaluator that this and this are the corresponding angles, this and this are the corresponding angles, and this and this. So So once you have done all these things, we get when we see your presentation, we come to an idea, okay, the student knows how, students knows to identify the corresponding sides and angles. So this method is the right method. Okay. So please practice the problems. So I hope you enjoyed the entire session today. In tomorrow's session, we will be going with more number of riders on similar triangles. Right. Until that, practice well. Stay home. Stay safe. Keep learning.